Hey, hi guys, welcome to my channel. So in today's video, we'll be discussing more about pandas and some other functionalities, including pivot table as well as group by statements. Let's try to read in a new data frame today or new table, which is called as cars. So we have information about cars in these data frame. Cars.csv, I guess. This is my data frame. It has information of certain brands or models of cars. MPG, then we have QSEC, all of the parameters or attributes associated with the model of a car. So let's try to see first how many different models of cars are there. So first, let's look at the shape. And if I want to find out the models of cars, I simply dbf of name dot unique will give me quite a lot of models, right? So if I do any unique, it'll give me number of such unique values in that particular column, which is name. And we have 32 different models of cars. So this is my df of. Now, if I want to find out number of EMs, which we have, okay, let's say number of EMs, which I have, dot value underscore counts will give me the count of each of the categories of EMs, A and M. Now let's try to see how many gears you are looking at. There are 3 gears. There are 3 types of maximum limit gears. So certain models have up to 3 gears, certain models have up to 4 gears, and certain other models have up to 5 gears. What are different types of cylinders which we have? Let's see, df of cylinder dot value underscore 8, 4, and 6. Okay, 8, 4, and 6. Now, if I want to find out how many of these 8 cylinders actually have how many different types of gears, right? So for that situation where I want to compare or dig more deeper into 2 discrete columns, why am I calling it discrete? Because this is discontinuous, right? These are discrete values, 3, 4, 5, and 8, 4, 6. Whereas displacement seems like a continuous variable. Weight will be like continuous variable. But cylinder, gear, AMs, these are all discrete values. Cross tab of gear, and then you can have df of cylinder. So you can easily understand this. Just like we had 8 in the cylinder section, and we saw that out of 8, 12 of them belong to cars which have up to 3 gears. There is no car with cylinder 8 size with gears 4. So that is how you can understand 2 different columns, discrete columns especially. Same thing I can do it using pivot table. So let us try to read another data frame. Tf is equal to pd.read underscore csv, or what is the data frame name here? Employee attrition. CSV data sets, right? df.head. Then let's do df.is null dot sum. Will give you number of missing values. There are no missing values in any of this column, right? There's one more attribute which I wanted to show you guys, and that is your df.describe. Now, what does describe basically mean? If you look at describe here, it is giving you the count, mean, standard deviation, minimum, 25 percentile, 50 percentile, 75 percentile, maximum value. Now, what are these 25, 50, 75%? Something which you are going to discover in the statistics playlist. Okay, but for now we know what is mean, what is standard deviation, what is maximum, what is minimum value, what is the count of the observations which we have. And that is why, and if you look at these columns, they seem to be all numerical in nature. Now if I do df.d types, integers and floats are being selected here, right? Columns which are categorical are not getting selected here. Why? Because categorical is in string-based columns, right? So if you have string-based columns, object columns, how will you find the mean or the standard deviation of this particular column? If I want to show any statistical properties of object columns, then you have to do describe of include is equal to, and then it will show you the count unique top frequency of the columns which are object in nature. Top means the mode. That particular label or that particular category in that column which has the maximum frequency. Okay, so if I say df of say department, okay, dot value underscore counts, research and development has the maximum count. That's why it is in, that is why it is here. So as the type of data changes, your statistical parameters you're looking also changes. So the way you understand data and what kind of tests, what kind of plots you're going to use, how will you analyze that, depends on the type of data you are dealing with. In statistics also, the first chapter will be understanding what data is categorical, what data is discrete, what data is numerical and continuous, and so forth. Now let's try to understand using the same period cross tab. Let's say I want to check, say, business travel and say department. I want to see which department, type of department actually travels the most. If I simply do this, you can see here, research and development, they travel very rarely because they are much a desk job. Whereas in the sales department, if you look at it, they travel quite frequently, 84, but there are people in the sales department who also travel rarely. Right now, if I want to find out the same kind of understanding with respect to attrition column, what is attrition? Attrition is basically means that the person has left the organization, right? Attrition, it is people who have left the organization. So if you look at the data set here, the attrition, which is yes and no. So let's look at what kind of values attrition have. So attrition has two values to begin with. One is no and one is yes. One means no means people who have not left the organization. People who have left the organization will be indicated by yes. So this is a data set which belongs to one of the most important business problems that the world is trying to solve today, and that is attrition. How to reduce attrition? Because when a person leaves the organization, to recruit him back, to recruit a replacement is a very expensive process. And companies typically tend to avoid attrition. If I want to see what is affecting attrition and what kind of business travel is affecting attrition, I can do something like this. So if you look at here, you can see here that people who travel frequently have the maximum chance of attrition. So let's try to see the proportion of people, leaving the organization to non-leaving the organization, not leaving the organization. So if I try to find out proportions, normalize equal to true. Now, if you look at this, yes, the probability the person does not travel of him leaving the organization becomes 0.8%. And if I multiply it by 100, to express it in terms of percentages. Okay. Now, if I want to do the same thing in Excel, how did you do it? So if you open the empty attrition data set first, you select whatever other data set is, convert to a pivot table. And then basically what you're looking at department probably as rows, or probably you are looking at, I think you're looking at travel, right? Business travel. You can remove this. And then we are also looking at attrition. And basically attrition will come in columns. Isn't this the same values which you are getting in Python? Here I'm normalizing it. If I've normalized this again, you have to, use some function to do that. So here it becomes much more easier, right? So in Python, you can achieve things in one single line of code without dragging and dropping, and it will take less amount of time. So how do I use the pivot function in Python? Okay, but before doing that, let me show you a couple of things. Here, you can also specify the column name, the row name, which we are trying to achieve. So let's say if I do call names is equal to, this is business travel, say travel, and comma row names. So my column name is actually, your attrition, right? Okay, ATT, and this is say travel. So you can see here the previous column name, which was before the original column, we can replace it, we can rename it, right, by using column names and row names. So if we really look at the cross-tab function, it basically gives us the count of the observations which basically belong to the conditions, to the specified conditions, right? So if I do not use any normalized function and simply do pd.cross-tab of both the columns, it basically gives me the count of those particular columns, right? Count of those observations which belong to these conditions. What if I wanted to find out or analyze some other column, other numerical column with respect to these columns which I have? What about that? So what I'm trying to say is, suppose I have travel and attrition as well. What if I also wanted to, in values, I wanted to find out, say, what is the average daily rate of people who actually, what is the average daily rate of people who belong to these conditions? So instead of sum, let me make this as average. So these are average daily rate of people who belong to these conditions. Non-travel and no, the average daily rate is 814, whereas travel rarely and yes is 765. So can we do that using p.cross-tab? Yes, we can. So there is another argument called values, which we'll have to use it like this. Say daily rate. Now, simply using the daily rate will not help, because if you saw in the Excel sheet as well, I use this, aggregator to change from sum to average. So this is the by default, the aggregator takes in sum in Excel. Whereas in Python, we do not have a default aggregator. So you have to specify what aggregation do you need. Do you need the sum, you need the median, you need the average, whatever you want to use. So here I'm going to use mean. So this value is actually the mean value of all the observations which actually belong to those two conditions. So if I had to repeat again, 814 is the average value of observations of 138 observations which belong to non-travel and no category. 765 is the average of 156 observations which belong to yes and travel rarely conditions. That is what aggregator function does. If you're not finding out the count, if you're finding out the mean, average, whatever it is, you need to have an aggregator, right? Because if you're finding out some average again, your other value, which is the third column which you're trying to analyze, has to be a numerical column. Now, can I now find out the say average hourly rate across different departments? There's one more function which allows you to do this, and that is group by. It's very handy, guys, and will help you group certain observations with respect to certain conditions. So what is the question? With respect to the department. So we'll group the entire data frame with respect to department. Okay. But what I'm going to find out with respect to department, I want to find out the average hourly rate. So what is the column under study? Hourly rate. I need an aggregator again, because fine, I'm doing group by department of the hourly rate column, but what after that? What mean, median, mode, whatever it is, right? So I have to do here, say this is the average hourly rate of different department labels. And if I do dot reset underscore index, it will convert the series to a data frame. Very simple. This is a series, this is a data frame. So if I want to show it in Excel, how does it look like? Let's say again, insert pivot table from table range. Okay. And here I want department, right? In rows. And then I want hourly rate, see, on values. And see, by default, it takes sum. So what I'll do, I'll have to change it to average. 64, 66, 65. See? Now there is one more function which will allow me to do that. That is pivot table. We have a pivot function in Python as well. We were doing it in Excel till now with pivot only, but in Python also we have pivot table. pd.pivot underscore table, say of department, and your values will be hourly rate Let's see if it has a aggregate function or not. Hourly rate. Okay. I think you need to specify the first as data frame. Yes. Now, what is the difference between all these three? If I simply use group by without reset underscore index, I'll get a series. If I do reset underscore index, I'll get a, it will convert, both the string. Sorry, if I use reset underscore index, it will convert these series to a data frame with two columns, one for this and the other one for this. However, if I use a pivot, my department remains an index, but hourly it is taken as a column. So what is the difference between these two? The difference between these two is that department here is an index, because you can see here in bold in color, and we do not have any default indexes here. So basically this is an index. So pivot table typically gives you an data frame with indexes of the column which you are doing aggregator with respect to. So basically pivot gives you a data frame just like group by with reset underscore index, but the difference is that in pivot table you'll have that column which you are using to aggregate or group it. That column will be given as an index column. So can I do group by with respect to multiple columns? Let's say department as well as what are the different columns here? Business travel is there and department. So let's do that with respect to business travel and department. Let's see, values equal to this. So index will be department and business travel, right? Same in Excel also. Same thing. Okay. And then let's use group by. Not only departments. So as soon as you put more columns, you have to use a list. Okay, if I do not use underscore index, it will give me something like this. We have two levels of indexes here. Okay, but it's fine, no problem. You can do set underscore index to make it look more simple. Similarly, you can do the same with pivot also. Reset underscore index. Same thing, no difference. So whatever way it suits you, I personally believe group by is much more easier to use. Okay, that is how I do it. Now, can I use group by not only to do mean, but different other aggregators, mean, median, standard deviation, minimum, maximum, everything? Can I do that? Let's try to see. So I can use dot aggregate like this. Okay. Let's say with respect to department, I'll use only one. So I can use multiple columns. So let's use dot aggregate. It basically requires a dictionary. Okay. What does the dictionary say? Which column you want to aggregate using which logic? So hourly rate, let me specify sum, mean, and say count. Let's see if this works. And there is one more column called age here, if I'm not wrong. So age, let this be again me. So not only can I select one column and do multiple aggregators, but I can choose multiple column with different aggregators. So let's see if this works. So hourly date has got sum, mean, and count. Age has got mean. Okay, we can do age sum also. These three aggregators which you see are for hourly rate, and these two are for age. So group by is a very interesting function and makes things very easier for us. The syntax is definitely less complex than pivot underscore table or query.cross tab, and you can easily understand this. You can in fact make it as reset underscore index to make things even more simpler. So here we have two levels of column. Also we can handle it, no problem. Okay, guys. So I think this is enough for today. We went through a lot of codes today, actually. And in this video, we looked into detail. How do we analyze data with respect to different aggregators? How do we use a discrete column, to aggregate on another continuous column and find out the average, mean, median, whatever it is, right? This is how Pandas allows users to analyze data in a much more granular level. All right, guys, I hope you enjoyed today's session. Looking forward to seeing you in the next video. If you have liked this video, please don't forget to like, share, and subscribe. Thank you.